All right, guys, we are back. We've got our next unit here. We're going to kind of start with it, and we'll get one standard done pretty quickly here. It's all about phases of water for this standard. Okay, so we have our vocab at the beginning here, and we have our objectives as well. I would like you to go ahead and read through those objectives, okay, so that we have an idea of just understanding what we're going to be talking about. So pause the video, please read through our objectives. So all of this unit with our solutions and phases of water has a lot to do with energy and temperatures, okay? So energy is really a measure of the capacity to do work, right? Or the ability of matter to do work, okay? So kinetic energy is the energy of motion, right? We probably know this from middle school. It's associated in chemistry with a temperature change, okay? Potential energy is the energy of position, okay? And so in chemistry, again, we often talk about electrical potential or chemical potential energy. Okay, this is associated, of course, with chemical changes, oftentimes not with temperature change. Sometimes we will start talking about chemical changes and temperature changes at the same time, and that's going to be changing both our potential and kinetic energies, okay? But our temperature, right, the temperature is a measure of the average kinetic energy of a substance's particles, okay? So a change in temperature, that's what this delta means. The change in temperature means that there is a change in the average kinetic energy, okay? It does not depend on a sample size, okay? So whenever we have particles, right, they have certain motions that are associated with them, which we're going to talk about in a little bit. But those particles maybe aren't moving at exactly the same speed, but the average of them is directly related to the temperature, okay? Then our heat, right? Heat is a quantity of energy, okay? It cannot be directly measured, right? It is not, our temperature we directly measure, right? It is just saying, hey, what's the average kinetic energy of our particles? We can measure that. But heat is really about the transfer, okay? It is can only be measured as it's transferred from one object to another, right? It always moves from a hot object to a cooler object. So it is transferred, and that's what we can actually measure, okay? So it does depend on sample size, right? A larger sample is going to need more heat to change that temperature. And our common units that we measure it, right? We measure in joules, we measure in kilojoules, and we measure it in calories. Okay? So cal is our abbreviation for that. In class, we generally only use joules or kilojoules, okay? There is a relationship between temperature and heat, but they are not the same thing, right? They are not the same thing. That's really important, right? Our temperature is all about that average kinetic energy, and our heat is about that transfer of energy, okay? So on the next page, right, we've got a Venn diagram. So heat, again, is the measure of a transfer of kinetic energy. The temperature is the measure of the average kinetic energy, right? They both have to do with the motion of our particles, right? They both have to do with the kinetic energy, but the heat is the transfer of energy. Temperature is the measure of the average kinetic energy, okay? So in our space here, I'd like for you to write a definition in your own words for heat and for temperature. Okay? All right. So on the next page, right, once we write those definitions, right, you can pause, come back. On the next page here, we're talking about our temperature scales, okay? So you probably have heard of these temperature scales before. We have Fahrenheit, Celsius, and Kelvin. We generally only use these two here, Celsius and Kelvin, okay? So absolute zero is what defines Kelvin, okay? And this is the temperature at which all particle motion ceases. There is no movement of the particles. It's kind of impossible as far as we know. We haven't really been able to see this, but absolute zero, right, comes from the Kelvin temperature scale, and it is at 0 Kelvin. But this is also at negative 273 degrees Celsius. Okay, so the thermometer is calibrated by two positions, right, for freezing and boiling of water. That's what our Celsius temperatures are determined by. So freezing or melting of water is always going to be at 0 C, which is 273 Kelvin, and the boiling point of water is always at 100 degrees C, which is 373 Kelvin, right? So it is a direct relationship, right, between Kelvin and Celsius, right? To be able to go in between those two, right, a change of 1 degree Celsius is the same change of 1 Kelvin, okay? But to be able to go in between the two, on the next page, we've got a little bit of practice here, right? Kelvin is our change in, or our degrees Celsius plus 273, and degrees Celsius is our Kelvin minus 273. That is the relationship between those two scales. So we should be able to go through these 5 questions, okay? So go through those 5 questions, and then we'll go on to the next page.